Snack on this. Imagine holding a single grain of sand in your hand. Now picture Earth being that grain of sand. In that case, the observable universe would be larger than Earth itself, by trillions upon trillions of times. Humans can only directly see about 6,000 stars with the naked eye, yet the universe holds 2 trillion galaxies. And the fastest thing in existence, light, moving at nearly 300,000 kilometers per second, is still too slow to easily cross the universe. Here's the kicker. By the time this video ends, light will have traveled 540 million kilometers, nearly 4 times the distance from Earth to the Sun. Earth's diameter is 12,742 kilometers. If the planet were hollow, you could fit about 50 moons inside it. The Earth isn't a perfect sphere. It bulges at the equator due to its spin. You actually weigh slightly less at the equator than at the poles. Our atmosphere is incredibly thin. If Earth were the size of a basketball, the breathable atmosphere would be thinner than the paint on its surface. The distance to the Moon is 384,000 kilometers, far enough that all of Earth's continents could fit between us and it. And here's a fun one. Astronauts have left mirrors on the Moon, and scientists still bounce lasers off them to measure the exact Earth-Moon distance. The Moon is drifting away at 3.8 centimeters per year. The Sun makes up 99.8% of the solar system's mass. Everything else, planets, moons, asteroids, is just crumbs left over from star formation. Every second, the Sun converts 600 million tons of hydrogen into helium, releasing enough energy to power Earth for 500,000 years. Mercury's day is longer than its year. It rotates so slowly that it takes 59 Earth days to spin once, but only 88 days to orbit the Sun. Venus spins backwards. The Sun rises in the west and sets in the east. Jupiter's magnetic field is so massive, it would appear in our night sky as twice the size of the Moon if it were visible. Saturn could float in water. Despite its size, it's less dense than water. If you had a bathtub big enough, Saturn would bob on the surface. The Kuiper belt beyond Neptune contains dwarf planets like Pluto, Haumea, and Eris. Eris is slightly smaller than Pluto, but more massive. Its discovery is what forced astronomers to reclassify Pluto as a dwarf planet in 2006. And then there's the Oort cloud, a spherical shell of icy bodies that extends almost 2 light years. Rare fact, some comets that swing past Earth began their journey millions of years ago, on the far edge of this invisible frontier. Proxima Centauri, our closest star, is so faint you can't see it with the naked eye, despite being our nearest neighbor at 4.24 light-years away. Light from Proxima left in 2021 to arrive here today, meaning when you look at it, you're looking into the past. Barnard's star, another nearby red dwarf, has the fastest apparent motion across our sky of any star. It's racing along so quickly that in just 9,000 years, it will become our closest star system. Not all stars are like the Sun. Some giants are so massive they could engulf Earth's orbit entirely. Others, like neutron stars, are so dense that a teaspoon of their material would weigh as much as Mount Everest. And then there are rogue stars, ejected from galaxies and wandering through intergalactic space, completely alone. Our galaxy is 100,000 light-years across, with a thickness of about 1,000 light-years. Yet compared to its width, it's flatter than a pancake. The Milky Way rotates, but incredibly slowly. If you lived for 100 years, the galaxy itself would have rotated by just 0.0004% of one full turn. Hidden in the dark are dark matter halos, invisible mass that makes up about 85% of the Milky Way's total matter. Without it, the galaxy would fly apart. Rare fact: astronomers recently discovered a giant void, over 1,000 light-years wide, inside the Milky Way. It's an empty bubble carved by supernova explosions, and our solar system just happens to be sitting on its edge. The central black hole, Sagittarius A star, is 26,000 light-years away. Despite its size, it appears tiny in the sky, about the size of a bagel on the moon, as seen from Earth. Andromeda is hurtling toward us at 110 kilometers per second. When it collides with the Milky Way, stars will rarely crash into one another. The distances are too great. Instead, the galaxies will swirl together in a slow-motion dance lasting billions of years. Between the Milky Way and Andromeda lies a trail of dwarf galaxies. Some are so faint that astronomers only discovered them in the past decade. The Virgo cluster contains thousands of galaxies, yet even this is just a small knot in the vast web of the universe. Rare fact: some of these galaxies are home to ultramassive black holes weighing 40 billion times the mass of our Sun. So large they defy current physics. Our supercluster, Laniakea, means immense heaven in Hawaiian. It is 520 million light-years wide and acts like a gravitational basin, pulling galaxies toward a mysterious region known as the Great Attractor. The Great Attractor itself is an unseen concentration of mass so powerful that entire galaxy clusters are being drawn toward it, including us. The observable universe spans 93 billion light-years. Within it are about 2 trillion galaxies. The largest known structure is the Hercules Corona Borealis Great Wall, a cluster of galaxies 10 billion light-years across. It's so big that it shouldn't even exist according to current cosmology. Cosmic microwave background radiation, faint leftover light from the Big Bang, still fills the universe today. It's the oldest light we can detect, dating back 13.8 billion years. Rare fact: the universe has a cosmic speed limit, but space itself can expand faster than light. That's why distant galaxies are racing away so quickly that their light will never reach us. And here's the staggering truth: as the universe expands, most galaxies we see today will eventually slip beyond our observable horizon. Billions of years from now, the night sky will grow emptier, until future astronomers may see only our own galaxy and nothing beyond. From a fragile blue planet, to the blazing sun, to the vast Milky Way, to the endless cosmic web, we are smaller than we can possibly imagine. And yet, we are stardust come to life. The iron in your blood, the calcium in your bones, the oxygen you breathe, all forged in the heart of dying stars. The universe is vast beyond comprehension. But against all odds, here we are, thinking about it. Or, as Carl Sagan once said, we are a way for the cosmos to know itself. We've reached the edge of the observable universe. But what lies beyond? The truth is, we don't know. The universe we can see, the 93 billion light-year bubble around us, is only the part where light has had time to reach us since the Big Bang. Beyond that horizon could be more of the same, or something completely unimaginable. One of the great mysteries is dark matter. We can't see it. We can't touch it. But it makes up about 85% of all matter in the universe. We only know it exists because of its gravity. Galaxies spin too fast. Without the invisible pull of dark matter, they would simply fly apart. Here's a rare fact. The Milky Way is wrapped in a vast dark matter halo, 10 times wider than the galaxy itself. Right now, as you watch this video, trillions of dark matter particles are streaming through your body, and you don't even notice. And then there's dark energy, even stranger. Instead of pulling things together, it pushes them apart. It's the mysterious force causing the expansion of the universe to speed up. Dark energy makes up nearly 70% of the universe, yet we have no idea what it actually is. Here's the kicker. If dark energy continues to dominate, galaxies will drift farther and farther apart. Trillions of years from now, distant galaxies will disappear beyond the cosmic horizon. A future civilization may live in a universe where the Milky Way is the only thing left in the night sky. But maybe our universe isn't the only one. Some theories suggest that the Big Bang wasn't a one-time event, but just one bubble in an endless cosmic foam. An infinite multiverse with countless universes, each with different laws of physics. In one, gravity might be weaker. In another, stars might never form. And in some, maybe life never exists at all. Here's a rare fact. The mathematics of inflation theory, the rapid expansion right after the Big Bang, actually predicts that multiple universes could form. If that's true, our entire observable universe may be just one tiny bubble in an endless cosmic sea. What happens in the end? One possibility is the heat death. Trillions upon trillions of years from now, stars will burn out, galaxies will fade, and the universe will become dark and cold. Another is the Big Rip, where dark energy grows so powerful it eventually tears apart galaxies, stars, planets, and even atoms themselves. Or perhaps the universe will collapse back in on itself in a big crunch, recycling everything into a new beginning. Right now, the evidence points toward heat death, an ever-expanding, ever-cooling cosmos. But remember, all of this vastness, from the smallest particle to the largest galaxy cluster, exists at the same time we do. You are part of this grand story, a fleeting spark in an infinite sea, but one capable of looking out and daring to ask, what's out there? And maybe, just maybe, the universe is asking back. Wow! If you made it all the way here, thank you. I hope this journey across the universe left you with the same sense of awe and wonder that it left me. The cosmos is vast, mysterious, and humbling. But the fact that you and I can explore it together, even through a screen, is something truly special. If you enjoyed this video, please hit that like button. It really helps more people discover it. And of course, don't forget to subscribe for more videos packed with mind-blowing facts about space, science, history, and the wonders of our world. Every week, I'll take you on new journeys that expand your mind and make you say, I had no idea. And if you'd like to go one step further, consider supporting the channel. You can check out the Buy Me a Coffee link in the description. It's like tossing a little fuel into the rocket that keeps this channel flying. Your support helps me create more content, upgrade visuals, and keep these cosmic adventures coming. Thank you again for being here. In a universe with 2 trillion galaxies, the odds of you watching this exact video at this exact moment are astronomically small. Yet, here we are. That's pretty special. So until next time, stay curious, keep looking up, and remember, you are made of stardust. I'll see you in the next video.